Welcome to the Walton Pi. Today we're going to be talking about what it means for something to be a cyclic group. So remember, we say in a group G, we say that a set S of elements generates the group if every element of G can be written as a finite product of elements in S and the inverses of the elements in S. And then a group is going to be cyclic if it can be generated by a set containing a single element. So we denote this as angle bracket X close angle bracket. So that just means that is the set generated by X. So if X is the generating element, in additive notation, we can write cyclic groups as the set containing all nx's, where n is an element of the integers. In the more standard multiplicative notation, we will write the group as x to the n, where n is an integer. So one example of a cyclic group is that of the integers. So every integer is a multiple of 1, which is our generator. Another cyclic group is going to be all integer powers of 2. So ... 1/8, 1/4, 1/2, 1, 2, 4, 8, 16, 32, and so on. That is a multiplicative group, and it's going to be a cyclic group, because here everything is generated by 2. We have 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 0 is 1, 2 to the minus 1 is 1/2, and so on. Okay, both of these two groups turn out to be isomorphic. So the way we can see this is we have a map from the integers to our group G, where we send an integer to 2 to the z. And that's going to be an isomorphism between the two groups. Now, if you don't know what an isomorphism is, don't worry, I'm going to make a video on that relatively soon. But these two groups are going to be essentially the same. They're written very differently, but in terms of group structure, they behave the same. So we can also look at finite cyclic groups. So a finite cyclic group with n elements is going to be z mod nz. So for example, z mod 12z, that's a group you've already seen before. Okay, we look at a clock. Okay, when we deal with time, hours repeat every 12 hours. So if we start at 1 o'clock and had 1 hour repeatedly, after 12 times of adding it up, we're going to be back at 1 o'clock. Okay, our finite cyclic groups are essentially clocks with just different numbers of hours. So here, when we have z mod 12z, we have addition, and then it just means that if you go over 12, you just reset back down. Okay, hopefully that made sense. That's a very quick synopsis of what cyclic groups are. I hope you have a great rest of your day, and good luck with all of your math.